All right, so this is a quick rundown of chapter 6. We don't have a lot of time left, so we got to move pretty quickly. So I've cut down this chapter considerably so that we can do it in a couple days. But we're just going to hit all the main points. All right, so this first video, I'm going to talk about solutions, solubility, and concentrations. If you look on this slide, this is the name of the chapter. Essentially, I'm going to cut out things like dispersions, suspensions that aren't really going to matter for us right now, right? So we're basically going to cover solutions and their concentrations and how to use those measurements, right? We'll also talk about dilution and some colligative properties because sometimes those concentrations affect cells, right? So we had isotonic, hypotonic, hypertonic way back in biology. So you should remember some of that stuff. But first, right, we got to talk about that solution in general. So it's a mixture of two or more pure substances. The solvent is always the thing that you have more of. Solute is whatever is dissolved in that solvent. Our solvent, 99% of the time, is going to be water, right? So you don't even have these things in your notes, and that's okay. You don't have to have all these definitions or anything. So don't panic and start writing those down. I had solute plus solvent gives you a solution in your notes because that's all you really need to know, right? For our purposes, we'll have something like salt, sodium chloride, that's dissolved in water. You mix it with water. Water is the solvent because there's a lot more of it than that salt. Otherwise, you just have wet salt, right? It wouldn't really be a mixture. But for our purposes, if I took salt and dissolved it in water, it would make a solution. And how we're going to write that is that sodium chloride is now aqueous. So we'll use that AQ, and that just means that it's dissolved in water. Right? So you don't need all that extra stuff from the first slide. Don't worry about it. Just know what we're talking about. When you dissolve something in something else, salt in water, you make a solution. So that depends on solubility, right? So the thing has to be capable of dissolving in your solvent. So that's where we got to add in this like dissolves like. So this is something from, like, this is just a saying that we use to remember that if you want something to dissolve in something else, they have to be similar. So for our purposes, what we need to know is that polar dissolves polar, right? So you can mix polar things together, but nonpolar dissolves nonpolar. Sorry, pen's not working. We'll just fix that. So nonpolar dissolves nonpolar. You guys already know that oil and water don't mix. If you have something that's nonpolar, it typically would not dissolve in something that's polar. So you have to have similar intermolecular forces, right? So when we talk intermolecular forces, right, one thing that we can talk about there, again, polar, nonpolar, those are intermolecular. Those are those things that we talked about before. But ionic compounds, right, are very similar to your polar covalent compounds, right? So that's why I can dissolve that salt in water, right? So I don't have molecules in that case. So it says involves intermolecular forces here. So I can have ions too, but as long as there are charges, right, that ionic is similar to polar interactions. Otherwise, there's some other things in terms of solubility. You can change the solubility of a substance by changing the temperature, right? You can get more salt to dissolve in water if it's hotter. It's an easier example to think about when you're talking like sugar in water. So you know you can get a lot more sugar to dissolve in a hot coffee than you can in a cold iced tea. So solubility increases as temperature increases for liquid and solid solutes, right? So if you have a solid solute dissolved in a liquid, if you want more to dissolve, heat it up, right? Pressure would have no effect on the solubility in that case, though. Whereas, generally speaking, solubility decreases as the temperature increases for a gas. So, if in the case before, right, a solid in a liquid is different than a gas in a liquid, right? Less will dissolve when it's hotter, when you have a hotter solvent for gases. So that's kind of like if I open up two pops and one's at room temperature and or I heat it up and the other one's ice cold, right? The one that's ice cold is going to stay fizzy longer. And that's actually a property of those solvents, right? When it's cold or hot. Otherwise, if you want more gas to dissolve, right, you can increase the solubility of the gas by increasing the pressure of that gas above the liquid. That's how they make that carbonated water to begin with. So these aren't going to be huge things as we go forward, but just to make sure we understand a few of those and have them in your notes just in case for the future. But solubility, like dissolves like, right? You can change the solubility of a substance by changing temperature, by changing pressure, right? That kind of stuff. Otherwise, our main focus is going to be on concentrations for this chapter. So again, I talked about how you could dissolve sugar in water. You can dissolve more sugar in water when it's hot, right? But saturated means that I have as much of it dissolved as possible. And that's defined, like I can find out how much salt can dissolve in water at a given temperature in a table somewhere in a book. But otherwise, unsaturated solutions are a little harder to define, and that's what we're going to be worried about. So if it's not saturated, exactly how much is in there, that's when we're going to need to start talking about these concentrations. So you need to know that we can express the amount of solute dissolved in whatever solvent, usually water for our cases, right, using concentrations.